We're not going to
We're not going to disclose yet.
Anyway,
yes.
ladies and gentlemen, let's once again put our hands together for Mr. Raghavendra Reddy.
There he is.
My name is Raghavendra Reddy. I'm the founder and director at Absolute Composites Private Limited. We're based out of Bangalore. Absolute is a materials and an engineering company which specializes in the design and manufacturing of unmanned aerial vehicles, and in that we specialize in high-speed UAVs. And besides that, we are also into special purpose machinery development. Again, very specific to the composite materials manufacturing processes. It's a very famous phrase by Leonardo da Vinci, who talks about, it's a lengthy statement, but what it says is flying is erective. So I got onto working on the flying machines when I was in third year engineering. I approached one company called Albatross Flying Systems, who were into the manufacturing of microlight aircrafts. I did not have a degree to join an engineering company, but the owner of that company permitted to work on Saturdays and on the holidays, and also sometimes in the evenings. So I was given a problem statement to reduce the weight of a structure which was weighing about 70 kilos, and to trim it down to about close to 50 kilos. So that was the challenge. And in exchange, I get to fly. So that was very exciting for me. Until that point, I never actually gotten onto an airplane. I had no experience of flying then. So I did my job, and I was rewarded. So I got to fly on that machine, and then it was fine. It was an unusual experience. But alongside, I also got to fly a hang glider. After I was up in the air about few feet above the ground, the kind of sensation that I experienced was something which remained throughout the rest of my life. It's been about 18 years now. I dream of flying, especially in a hang glider, because that's the closest you can get to flying, in the sense, that's because no power, you have to use your body strength to maneuver the aircraft. And I still love hang gliding, right? So, while it is very interesting, while it is very, fascinating also to fly the hang gliders, but unfortunately, it calls for a lot of logistics. For example, you need to have a roof rail, you need to have a kind of an SUV to carry it, and and also a hill to launch a hang glider, right? So, and then I realized this is something where I can't just get out whenever I feel like and then be up in the air, right? So, and then it was a very vague idea, vague dreams coming. What kind of configuration that is appropriate for making one fly, right? So it was still very, abstract at that stage. And then I was thinking of laying down a broad qualitative requirements for that, how it should be. What kind of boxes we have to tick. So it should be lightweight and compact. It should fit into a pickup truck, very easy to set up. And silent in operation, because I was drawing parallels with hang gliders also. And 10 to minutes of endurance is, I think, pretty much okay. And we started building one small little personal air vehicle. So this is that. It's powered by electric ducted fans. There are about 8 ducted fans on it. It's quite easy to assemble. It has a 5 kilowatt hour battery pack, which weighs about close to 30 kilos. And then we made some flying attempts, and so that's basically the specification. It's electric ducted fan propelled. I lost the display. I'm sorry about that. Yeah, it's back. Thank you. Thank you. 8 EDFs and yeah, we just got about 55 seconds of endurance on it with a 30 kilo battery and a pilot weighing about 70 kilos. All of weight of the whole system, including the pilot, was about 130 kilos. So that's a unmanned attempt. You can see some of our team holding these bubble sheet rolls, just in case if it falls off, then they could just throw it in to save it from falling off. Yeah. All right. So we were not happy with what we achieved with that particular configuration, and then even without solving the problem completely, we got into another configuration because we understood that there is no point in improvising on this because we already understood the limitations, and then we thought of building another flying machine with these requirements. It should be wearable this time. So last time it was a kind of a strap-on system, but this time it is wearable, where we could carry it like a backpack. Lightweight and compact, and to fit on a car boot, not on an SUV though. Again, easy to set up. Noise we had to trade off because we understood that electric propulsion has got limitations, so the flights of that kind are not going to come that silent. So even engines are okay. So the target endurance can be somewhere in between about 10 to 15 minutes, and easy to fly again, easy to set up. So, and then we started dreaming of the jet suits, right? Okay, what kind of configuration, there are so many examples from the comic movies and Iron Man movies, Superman movies, so on and so forth. So we started studying about what kind of developments have already happened across the world, and then this was the first successful suit that was built by Bell Aircraft Corporation in the US. It was powered by hydrogen peroxide, and the company is Bell Aircraft, and based on that they made a chair. Pretty much the same kind of technology, but you don't have to carry, you can rather sit and fly. And then an improvised version of that. Why? Because this was giving an endurance of about 60 seconds, and to increase the endurance they used turbojet engines, which was ATF fueled, and this was also by Bell Aircraft Company. And then these were old developments, somewhere in between 60s and 70s. And then some of the latest developments by Frankie Zapata, who is a Frenchman. It's called Hoverboard. It's based on the Green Goblin character. And then Mayman from jetpack aviation, Buck Rogers style. Buck Rogers is again a kind of a concept, and this is Iron Man style. Richard Browning, he's very popular. He's from UK. It's Iron Man style. And then these are some of the success stories of the jetpacks that we were looking at. So it's a small clipping of that. So all these successes just did not happen overnight, right? You know, they had to fail, they had to try, retry, and then get it right. So one short clipping of their failures as well. It can be as stupid as this. It's a failure. He's not able to control it. It's a failure. That's our suit. So that was prototype 1. But we had safety. Just attempting to fledge. All right. So with all this information, with all this examples and studies, we thought, I think, we have to build something, you know, that is inspired by some of the concepts of the jet suit that were already available, and also try to improvise whatever we could. So the problems to be solved to come up with a practical suit were starting the engines in vertical position, because we had by then decided that we'll go with turbojet engines. These turbojet engines wouldn't start in the vertical position, because on the backpack, you know, they have to be placed in vertical position, right? So we had to do conversions for that. So we had to start in vertical position and making engines run on diesel. Why? Because jet A1 is very explosive. You know, even if there is an arc, it would catch fire, and it's almost impossible to put it off. And ultralight composites body, that was our strength though, because we are into composite materials. A lightweight composite fuel tank, which was again new to us. Central engine governor for uniform thrust. Central control distribution unit, because once we apply any control, all engines should accept that control, and we need to transmit the controls to all the engines. And center power distribution unit, because we also have to distribute the power and also the fuel plumbing. and custom battery pack for this, because to start the engines, it's a lot of energy intensive process. So we had to customize a battery pack for high discharge rates. And harness, of course, that is again something which is very safety critical. We had to look into, what is the most compliant harnesses and the buckles, how many number of points, in case if there is an emergency, then how does the pilot exit? If he has a single point buckle, then it's going to be very risky, though it is convenient, but whether it's going to be a 5-point harness or maybe 2, 3, so that we don't, we had no idea then. And then the training rig, because having learned from all these examples, we want the pilot to be safe. Right? And hence we had to come up with a training rig to start with. So materials, we were already working on the turbojet engines by virtue of we manufacturing high-speed UAVs, and we also had assembly and balancing machine to assemble and maintain these engines, but because these engines come with a limited time before overhaul, about 15 to 20 hours. And then we also had the test rig to test the engine for all the parameters, fuel flow and the thrust and RPMs, so on and so forth. And that's because of this virtue, we being into unmanned aerial systems. And short clipping of what we do. So these are bread and butter. And this was not a project that we started because we had a contract. It was pure passion, I would say, or maybe some kind of madness, like I said in the beginning, that somehow we need to make something so that we could be up in the air whenever we want to in few minutes, right? And we have a team of 15 to 20 engineers, and everybody is busy in their own thing, and for them it did not make too much of meaning or sense. And then I approached all engineers in my team that I have this idea and it appears to be possible, and we have most of the material, but unfortunately there was not too much of interest from them. And then in my team there is one guy, his name is Alam. His education is only 10th standard, and his age is just about 24 years, and he came to me when he was 18-year-old, and he came as I was here last night where I saw all this thing was being constructed. He came to work in a event management company to kind of help, and I think he was doing carpentry or something of that sort. He wanted to go home, but his contractor was not ready to send him, because it would rather cost him some money, 1,000, 2,000, something like that. And then somebody told me that, there is one chap like this. I said, hey, theek hai, aa jao. And then I told him, what do you know? He said, we were doing some welding, and then he said, I can do welding, which he actually did not know how to weld. But I offered him to weld, and then I could see that he was improving in every attempt he was making, he was improving. So, and then I said, okay, tum aa jao. And so that's how we joined, and then he is now able to challenge any of the engineers in our team. I can't stop praising that guy, because the kind of improvement that he has shown, the kind of interest that he has got, irrespective. And he comes from a rural village somewhere in the north, maybe Bihar, I believe, right? So he built that prototype 1. He could do CAD modeling, he could do the molding part of it, he could assemble the engines, he could run the engines. And then I wanted him to fly first, and then he made some attempts on it. But he again got too busy into building the prototype 2. So that's his story. And after once the prototype 1 was made and it started showing some results, then entire team came, and then now they started supporting in building prototype 2. So That's Alam. So the first prototype. So this is the first prototype. It has 6 engines, and this is the specification: 30 kgs empty weight, pilot weight 60 kg, 6 engines, total thrust is 180 kgs, endurance is 5 minutes. It's fueled by diesel. And then we built a training rig. This was also built by Alam. You can see Alam sitting on that makeshift cradle, which was an inverted stool. So this is after completion, and this is the first attempt. So these are all the failures. And then while we were doing this, there was an RFP, a request for proposal from Indian Army Infantry 7, asking for 48 jetpack suits under emergency procurement. It was issued on January 24th, and the demonstration was supposed to be made on the 23rd or 25th, something like that. We just had about 3 weeks because we also had to travel. So we came up with prototype 2 to suit the requirements of that particular RFP. And then we came up with a second prototype, which was built in about 3 weeks. And with these specifications, about 40 kg empty weight, pilot weight 80 kg. We increased one more engine to meet the requirements, and total thrust about 230 kg and endurance about 8 minutes. Altitude 3000 meter because that was the requirement. And then here is a short clipping of how we built the jet suit. So most of the activities we used to do in the night because that's the only time we had. Otherwise, our bread and butter is building unmanned aerial vehicles. So most of the things you can see in the night, both building and testing. So prototype 1 and 2. This is prototype 2. So the control unit. So this is the fuel caddy to refuel. So people were sleepless because of the demo that we had to give to the Indian Army, and they had provided a small little quarters to. So that's Alam, who was nodding off because of lack of sleep. So these were some of the videos at the demonstration site, and we were given a Medal of Excellence by the Army Airborne Training School for attempts. Thank you very much. For the kind of attempts, that's it. We were not really successful. We did not tick all the boxes of the requirements, but yet they kind of appreciated, and they asked us to work more and also work very closely with them, take the requirements, and also they are giving some time now. So this is another short clipping where we got some success. So the background music is from the movie called Muthu. It's Rajnikant's movie because in South India he's considered to be someone who would make impossible possible, right? So it's notional to that, yeah. So that's the sound of the engine, but actually deafening noise, I must say. The noise is so loud. Organizers asked us to, demonstrate here, but I said, indoors, impossible. Let's not, thank you.
Absolutely, we were worried we'd burn the stage down. But Raghav, absolutely brilliant presentation, so exciting. But you have to show us the actual piece. I know everyone's seen one outside, but it would be great to have one here on stage.
We got it here. So what you see there outside was a 3D printed model. We also got the actual model along with the pilot. Jay must be standing somewhere there.
Yes.
Jay,
Jay, if we could have you on stage. Ladies and gentlemen, round of applause. This is Jay. He's the actual pilot.
He's the pilot. Jay
Who's not going to
Bahakar.
fly?
Yeah. So Jay joined us as a flight test engineer for testing the UAVs. And then we were all malnutritioned, right? Entire engineering team was quite malnutritioned. And then we found him to be quite healthy. And then we asked him to volunteer. He was more than happy. He's a very shy guy, but very strong in what he believes. Like how he looks, he is quite strong, I must say. Yeah.
So
Thanks, Jay, for volunteering indeed. He's not getting extra money for taking all the risk in his life. Yeah. I mean, it's pure volunteering. Yeah.
Thank you so much,
Yeah.
Jay. All respect. That's really great to push forward this. But Raghav, we would have loved to know more, and like you said, we would have loved to see the demo of the suit also. But we are absolutely running out of time.
Sure.
So thank you so much. You have another slide?
I just wanted to conclude saying that,
Sure.
what's the future for us?
Yes, absolutely.
So we have system limitations where it demands great physical strength, dexterity and agility, very high load on the shoulder, not everybody can fly that, and cannot walk long distances with the jet suit because it's quite heavy, and both hands fully occupied. So pilot says that I can't even scratch my nose. So, I mean, what's the point? I need something else which is more comfortable to me so that I can do something at least, right? My hands should be free. And this is very unstable, less endurance and range, fully manual, lot of control load on the pilot and less utility, I would say. Let me be honest about it. So now what's next for us? Advanced all-new design for hands-off control for flying and less training and less skill dependent. Electronic stability in the sense, I'm talking about autopilots for this. We already are into building autopilots. So we would be introducing autopilot onto this. And autonomous flight controls, it could be optionally piloted. In case if the pilot is not available, some material need to be transported from place A to place B, or maybe even somebody is injured, then that should be possible because of autonomy. And exoskeleton support, if somebody wants to wear, we'll be giving a lower exo support in the next versions. And uncompromised safety and reliability. And compliance with airworthiness and the regulators. We aspire of building a national air display team to participate in some of the international competitions and also some of the shows. And we'll have a training academy. We are formulating the courses for this, and a dedicated development center as of now, it's only a part-time small activity for us. But with the kind of interest that we are seeing, I think this deserves a dedicated facility now. Yeah.
Absolutely. Sure.
Thank you.
I'm wondering if Jarvis could scratch Iron Man's nose.
That is something for which we'll have to watch those Iron Man movies. Thank you so much, Mr. Reddy, and thank you to Jay also. Ladies and gentlemen, round of applause for Mr. Raghavendra Reddy.
You.
Thank you, sir.
Thank you.